Hello and welcome. In this video I'm going to explain how to use this what's called a traveling microscope to try to determine the diameter of a pinhole. So you can see here we have a 600 micron pinhole. Now the issue here, you may wonder, well, if we already know that this is 600 microns, why would we have to measure it? Well, the issue is the manufacturer says it's somewhere between 540 to 660 micron. And I think we can get a little bit more precise than what the manufacturer is quoting for the tolerance here. Okay, and so what we have is a light box. There's a light switch in the back. You can look through with your eyes here. What you want to do is actually look through and get it lined up. And if you look through here, you see that there's a crosshair. I don't know if this is going to work, but I'm going to try to see if putting this up. Oh my goodness, that works pretty well. So you can actually see the pinhole. You can actually probably barely make out the crosshairs. Now those crosshairs are going to move. Geez, I wonder if I can get that repositioned in such a way that you can see this moving. But in any event, you're going to see the crosshairs move. If you're looking through here with your eyes, you're going to see as you use this knob here to turn the entire apparatus, this is moving this display from left to right, that you can actually transverse the space. And what you want to do is get the pinhole on one edge of get the crosshairs on one edge of the pinhole, walk it across to the other, and then simply take the difference. So now the way we're going to go about doing the measurement is to begin seeing that we're in centimeters. We're going to read to the nearest 0.1 centimeter just off the display here. What we're going to note here is that we're at 34, not quite to 35, and we've just gone across the 0.5 marker. So right now I can say we're at 34.5 centimeters, and then the next placeholders are going to be read off of the dial here. Okay, and so we've made it across the 0.2, not quite to 0.3, and then we've made it almost to 27. It looks like we're just shy of 27. Okay, so we're going to be at 26, so 34.526. We haven't made it to the 7. You see how we've gone across the 25 and 26 marker? And then you can interpolate from there. I'm going to say that's about 0.7. So you're just like interpolating. Let me get a little closer. Just seeing where that marking is. I think it's closer to the 27 than 26 mark. Okay, so this placeholder here is that one that you're getting some like plus minus in this placeholder here. You also get a little bit of uncertainty in where that edge is actually on the edge of the pinhole. It's a little bit hard to tell. And so then that would be your before, then walk across to the other side and then take the difference here. Only issue to point out is you got to turn the same direction. So if you're turning this way, line up the pinhole on the one side, keep turning the same direction to the other side, because there's a little bit of play here. If you notice, you don't want this where nothing's moving here. This is just the play in the instrument. So go the same direction. You can also line it up on one side and then keep going that same direction. So that's the only sort of nuance here, is turning the crank in the same direction. Okay, so that's how we can get a more precise determination of a pinhole. You can use this for practice. Obviously you want to use your real pinhole that you're using in your experiment. And like we mentioned before, try to mark your orifice so that you know you're using the same one each time. Otherwise you got to come back here and take a new measurement on a new day.